Good afternoon. Thank you for joining us today. My name is Andrea Watson, and I'm Tualatin Valley Water District's Communications and Public Affairs Supervisor. Your topic today for Talking Water is going to be spring irrigation preparation. And we're delighted that you took some time out of your day to join us. We find these seminars to be very helpful to our customers based on those that have participated. So we are continuing to do these approximately one per month. This is the second edition for 2022, so we do more of them in the summer and fall. And the format today is going to be a presentation followed by a question and answer. We are very eager to answer any of your questions. Hopefully they'll be the topic today, but we are willing to accept any questions. We have a number of subject matter experts on the call with us today, and they will attempt to field your questions. And if you are successful in answering or asking a question that we're unable to answer, we'll get back to you after the event by email or phone so that we can address your needs. A little housekeeping about the event on Microsoft Teams. For those of you that are joining us today on the app or on a computer, you will see this little toolbar and you'll see the slides. If you're joining us by phone, you get an audio experience and we are happy to support you in any way we can, but some of these features are not available for callers who join us by phone alone. The slides and the recording from today will be posted on our website after the event, and you can reach us at 503-848-3000 for any follow-up that you might have, and we will get back to you. The way the question and answer works, there's a little icon and it looks like a thought bubble with a question mark in the middle of it. Again, for those of you on the computer and app, if you click on that, you can type in your questions. And we have staff that are supporting the chat function. The question and answer will be moderated at the end. And so it does take us a few minutes to review those questions. And if a lot of questions come in at one time, it can take, up to 5 minutes for us to publish your question. So just be patient, please, and we will get to all the questions and answers, and we will stay on the call until the questions and answers are done. Other than that, we try to keep our presentation short to allow the maximum amount of time for question and answer. We are a special district, which is a form of government that's somewhat unique. Not every state has it. And basically what it is we're a single function agency. So we provide drinking water, and that's for drinking, for recreation, as well as for fire protection to residents and businesses. The gist of our presentation today is aimed at residential customers. So if you're a commercial customer, we have a different line of services we can help you out, but the kind of equipment that we're going to be focused on today is the typical residential equipment. So also just as a reminder, we are a government agency, so we do operate with a non-discrimination, no harassment. So please keep your comments free of profanity and things like that so that we can publish them. We will screen those out and we will still try to answer the core of your question, but we do ask that you be respectful of those that are joining us today. So with that, I'm going to ask Steve to advance the slide here for me, and I'm going to get to the meat of it and introduce for you today who's going to be with us. Our Chief Executive Officer, Tom Hickman, is unable to join us today, but we do like to introduce him. He joined the organization in August of 2019. He brings a lot of experience from the city of Bend, and he is unable to join us today due to a family emergency, but we are trying to let people know that he's very accessible and you can join him in almost all of these events. I think he's only missed a handful of the 20 events we've hosted so far. And go ahead, next slide, Steve. I'm going to introduce your speakers today. We're going to have two speakers joining. The first is Steve Carper. Steve is a conservation technician. He joined TVWD in 2006, and in his role, he focuses on coordinating the conservation programs for the district. He has over 30 years of experience in the Willamette Valley irrigation and landscape industry with construction, irrigation, and maintenance. He's also served 2 terms on the Oregon State Landscape Contractors Board, and he's a certified landscape irrigation auditor. So he'll talk more about that, I'm sure. Outside of work, he enjoys brewing beer and playing his guitar, and there's quite a collection there muted out in the background. He and his wife, Debbie, live in Beaverton and are proud parents of a young son. Your second speaker today is going to be Cal Howell. He's a senior water quality inspector. He joined TVWD in September of 2020, and he comes to us with a decade of experience as a regional trainer at BMI. And BMI provides training and operator certifications in cross-connection control, backflow testing, confined space safety, and other aspects of the water system operations. Cal has traveled to water systems across Oregon, Washington, and California to help them develop their own cross-connection control and inspection programs. And we're pleased to have him presenting today on the backflow prevention assemblies. Cal recently got married to his wife, Hillary, and they are expecting their first human baby later this year. In the meantime, they've been parenting one bunny named Strawberry. So with that, I'm going to turn it over to you. Thank you for joining us today.
Well, good morning, everyone. Thanks for joining us. This is Steve, and I'm going to start things off. And as Andrea mentioned, we're going to talk about residential irrigation systems. And in order to irrigate efficiently, it's really important that we tune these systems up every spring. And believe it or not, summer is right around the corner. It may not seem like it the last couple of weeks. I haven't been able to get out and get anything done in my mud pit out back for a while. So I'm happy to see the sun today and hope that it sticks around. But eventually things will turn to a point where we will need to start irrigating in Oregon. And there's just a few simple things that you need to do every year to make sure that your system is performing efficiently and optimally. And we're going to help you do that today. So to get started, we just want to let you know about some simple tools that you'll need to get the job done right. A large screwdriver is going to come in really handy to help you access some of the valve boxes that your equipment may be located in throughout the yard that we'll talk about today. The automatic valves, shutoff valves, things of that nature. A small flathead screwdriver will come in really handy for adjusting certain pop-up spray irrigation nozzles. In other cases, you may have a spray nozzle or a rotor nozzle that requires specialty adjustment tools, and I'll show some images later on in the presentation. But it's good to be aware if you need those types of tools and have those handy. So we'll help you try and figure out if that's something that you'll need to seek out and where you might be able to find them. Also, a small hand spade is really useful. One, if the moles or the gophers have filled up your valve boxes with dirt, it's really helpful to clean those out and get them accessible so that you can get the work done. But also for making minor adjustments to sprinkler head position. It's a really useful tool to get things done quickly. A valve key, I'll show you a picture of what that is in a later slide. And a pair of gloves, obviously, to keep your hands safe from critters that might be in the valve boxes or any superficial nicks and cuts on your knuckles. A flashlight, not mandatory, but can be helpful. Hopefully you're not doing this at night, but some of these valve boxes are dark, and if you're accessing some of the things that we're talking about today, a flashlight can obviously help illuminate things a little bit for you. And then if you've got knees like me, knee padding can be useful. Getting down on asphalt or gravel or other surfaces like that, it can just be a really comforting thing to make things a little bit more pleasant. So to start out with, the first thing we need to do is to locate and close any manual drain valves that may have been left open from the winterization procedures that we went through last fall when the irrigation system was turned off at the end of the watering season. Some valves require special tools or a key, and that's what we see on the image to the right. The valve that we see in the second from the right image, that cross type handle is to operate that. It's a lot easier if you have a key, as we see demonstrated here to the right, to operate that. If you don't happen to have a key, you can use a pair of traditional pliers or channel locks to make it a little bit easier. It can be a little difficult to operate that type of a valve with your fingers if you don't have a little bit of a mechanical assistance there. In the image to the left, this is a picture of a irrigation electronic valve manifold, and this is a typical place where you may find a manual drain valve. Generally, they are located at the terminal end of any lateral lines that you may have on your irrigation system. Sometimes they're installed on their own at a low point in lateral lines or drain lines, but typically they're included with some of the valves, either on single valves or in a manifold situation like this. And in the real world, you're also going to see this manifold covered with a valve box, typically with a green cover installed at grade. And so we'll have an image of what those valve boxes look like on a later slide as well. Keep in mind, not all irrigation systems have manual drain valves installed. So if you go looking through all the things that you can find, the different valve boxes, and you don't see anything that resembles these valves here in the center images, don't worry about it too much. If you turn on your irrigation system and you don't see water sprouting out from the ground or any obvious signs of a leak, chances are you don't have a manual valve if you're trying to assess that, say in an irrigation system that you acquired in a new home that you didn't have built. So good thing to keep in mind, that don't worry if you don't have them, but if you do, make sure everything is closed down before we proceed to the pressurization of the system. Some gate valves, it's important to keep in mind as well. This image to the right, some gate valves actually have drain caps, and so it's a good thing to kind of reach down and feel the side to make sure to assess if you have this type of a cap, and if so, just make sure that that's tightened down good and snug, just because if you accidentally pressurize the system with that cap loose, they can pop off pretty easily, and they're small, so they're lost quite easily. So just make sure that you've got all the drains are closed down, all your caps are sealed up tight. And then at this point, we will shift our focus over to the backflow prevention device. And at this point, I will turn the presentation over to Cal, who's going to talk a little bit more about those devices specifically. So Cal, take it away.
Awesome. Thank you, Steve, and hello to everybody. So to talk about the backflow preventers, there's actually up to 5 different types of backflow preventers that you can see installed to your underground sprinkler systems. However, in Oregon, and specifically here in the district, these are the most common types that you see here. On the left is the double check valve assembly, which is by far the most common, even of these 3. The middle is a pressure vacuum breaker assembly, and then on the right is an atmospheric vacuum breaker. All backflow preventers, they're designed to accomplish the same primary purpose, which is to protect your drinking water and the community drinking water from contamination. In this application, the backflow preventer is installed at the point where your irrigation system connects to your home's plumbing system. It's a mechanical one-way valve. So it allows water to flow in just one direction into your sprinkler system. However, it will prevent any water from your sprinkler system to flow back into your drinking water, and as I said, into the community's drinking water. So long as it's functioning properly, which is why we'll talk about testing and maintenance later on. The double check is usually installed in the ground prior to your solenoid valves, which is housed in a plastic irrigation box, a lot of times with a green lid. The pressure vacuum breaker is also prior to those zones, but is actually always above grade because it has to be 12 inches minimum above all the downstream piping. So in this case, it would be your sprinkler piping, sprinkler heads, drip irrigation, these types of things. The atmospheric vacuum breaker that we see there on the right, it's similar to the pressure vacuum breaker in that it will always be above grade. However, you need 1 atmospheric vacuum breaker per zone, downstream of each zone, which typically then results in you having multiple atmospheric vacuum breakers. Both the double check and the pressure vacuum breaker, they require annual testing. Therefore, are equipped with test ports and shutoff valves for these certified testers to conduct the test, which will be helpful for us to pressurize our system and as we go over some of those operations of those valves. The atmospheric vacuum breaker, it's non-testable, so it doesn't require any annual testing. However, it does require an initial inspection when it's installed, and then a re-inspection anytime it's moved or if there's alterations made to the sprinkler systems. And on these, there's no ports that help us or that we need to close in order to pressurize the system, as we'll cover with the testable type of backflow preventers. So on the next slide, I'm actually going to show you the basic operation of the shutoff valves and the test ports, of the double check valve assembly being the most common in order to pressurize your system. So the double check, it has 2 shutoff valves and 4 test ports. In this picture, the shutoff valves are the green handled valves, and the test ports have those black caps and the flathead screwdriver slots. These test ports can be turned in either direction. If the slot is perpendicular to the port, as indicated in the picture on the left, it is closed. If the slot is in line or parallel with the port, it is opened. So similar with the shutoff valves, if the shutoff handle is perpendicular to the shutoff valve piping, it's closed, and if it's parallel with the shutoff valve piping, it's open. So if your backflow assembly looks similar to the picture in the middle, you'd see there then all of the test ports and shutoff valves are actually slightly opened, because if it was properly winterized last year, that would have been a good way to drain that system. So what we're going to now go over is how to properly close these valves and open the shutoff valves to introduce pressure into your system. So next slide, please, Steve. Okay, so first, before closing these valves, we'll want to locate our isolation valve, as Steve had discussed. It's typically housed also in a green lidded box. However, it's a cylinder more like what you see here on the left. Sometimes if you're not finding a circular valve box like this, it can also be in the same rectangular valve box that houses your backflow assembly. And even in some cases, if you don't have an isolation valve, the isolation valves on the backflow assembly, or excuse me, the shutoff valves in the backflow assembly are used as an isolation valve. So a few different variations there of what you might run into in your situation. But what we see here in the middle is a gate type valve. So like a typical faucet, you start turning that to counterclockwise, it's going to open the valve, and you start closing it clockwise, it's going to close it, or as I normally say, righty tighty, lefty loosey, to close that one. And then on the right hand side is a typical ball valve, which is actually very, very similar to the assembly, the double check that we looked at briefly, to where when it is parallel with the shutoff valve piping, it is open. When it's perpendicular to that valve, it's closed. So the picture on the right, that one is in the open position. And so before, as Steve had said also, there's those drain ports sometimes on those valves that we'd want to make sure we snug those up prior to opening these. But before we actually would open this valve, we want to take a few more steps, and we'll look at that in the next slide. Next slide, Steve, if you would, please. Thanks so much. So to properly pressurize our system, here's some of the first steps we want to do. We actually want to first start by closing the number 1 and the number 2 shutoff valves on the backflow assembly, and closing all 4 of the ports with a screwdriver, as indicated in that first picture. Then what we're going to do at step 3 is now open that isolation valve, and that's going to bring pressure up to the backflow assembly and stop at that point. So we want to check it for any leaks at this point in between that space. Sometimes it's a matter of inches, sometimes it's a matter of feet, but that's what we're going to check at this point. Once we verify that, we're going to now open the number 1 shutoff valve on the assembly. And the best way to find the number 1 shutoff valve is there's 3 ports that are in between both of the shutoff valves, and then there's one of those ports that falls to the outside of a shutoff valve. That test port that falls to the outside of a shutoff valve, well, first, that's your number 1 test port, but more better of what that indicates is it's always on the outside of the first shutoff. So we want to find that first shutoff valve and slowly open that up, which introduces pressure into the backflow assembly. Again, at this point, we want to verify there's no leaks from the body of the assembly or leaks from the test ports, which a lot of times might indicate we didn't close it up completely. Once we have pressure in the backflow assembly, now we're going to introduce pressure up to your solenoid valves, and this is where we're really pressurizing the sprinkler system. So this one is most important to do very slowly. As we open up the number 2 shutoff valve, this is going to now introduce that pressure to the solenoids. If we do that too quickly, we can water hammer things downstream. We can cause breaks in piping, breaks in our solenoid valves, and things such as this. So by opening it slightly, you'll hear the water start to flow. I normally stop at that point and allow all that water. You'll hear the flow of it come to a stop, meaning it's now filled, and then you can finish opening that number 2 shutoff valve. So, of course, if you have more questions about that, please bring those up in the Q&A, but let's go ahead and move on to talking about testing requirements for these backflow preventers. So the district, we require backflow assemblies to be tested annually to confirm that they're operating properly. And as a district customer, there are 2 ways to accomplish this annual test. You can hire your own state certified tester to complete the testing, or you can subscribe to the district's Gold Plan annual testing program. So first, let's talk about the Gold Plan. Currently, actually over half of our residential customers are enrolled in this Gold Plan program, where we take care of the testing on your behalf through our contracted testers. It is an optional service for most of our residential customers. So if your assembly is located readily accessible in your front yard, maybe by your meter or anywhere in your front yard, often on a side yard or in a flower bed, something of this sort, or if it's behind an unlocked gate, then this program you're eligible to be in the Gold Plan program. Now, if your assembly would require an appointment, so such as being in a garage, a crawl space, or behind a locked gate, it would then be more suitable to schedule your tests with an independent testing company. To subscribe to this program, you can visit our website, and you can submit a digital application through our website, and that's really fast and easy. You don't have to print anything out. You don't have to attach anything to an email. It's all done through the website and is very streamlined and efficient. You've likely received your second notice by now, so if you check your mailbox, I'm sure you'll see it in there. And one thing that's important is if you want to be in the Gold Plan for this year, you'll want to subscribe by June 1st is the cutoff to be included in this year. So please subscribe prior to that to be included in the program. It is the Gold Plan subscription. It is $35 per backflow assembly, so many of you would likely just have the one. And this is added to your water bill once annually. So it's a reoccurring bill, but just one time per year. Once we arrange your test and the tester goes out and completes this test, they don't need to call you or email you if your assembly is readily accessible, but what they will do, so you know when the assembly is tested, is leave a door hanger on your front door indicating whether it passed, failed, any notes that they may want to bring to your attention, and then the date of the test. Now, if the assembly did fail a test, the district actually credits you $50 towards any repair of the backflow assembly itself, as long as you use our contracted tester. And so with that, we'll go to the next slide. And so many customers, you may already have a tester that you're completely satisfied with, or you may want to just call around and find another testing company and not sign up for the Gold Plan. That is absolutely okay. You would have received your first notice back in February, and most recently your second notice, which was mailed out just last week. And it's just reminding you that our due date for those non-Gold Plan customers, non-Gold Plan assemblies, is September 1st of each year. So you'll want to make sure your assembly is tested prior to September 1st. Now that's the cutoff However, a lot of you may end up getting your assembly tested in the springtime when the system's first being fired up for the season. And finding a tester, if you've yet to have one and would like to find a tester, I really suggest asking neighbors, friends you might have in the district, and they may have a recommended tester for you to call, get a quote from. Typically between $30 to $50 is a range of what a test would cost. Since you're contracting with a tester, you'd want to just be aware that testers are required to submit those test results on your behalf to the district. And so if they forget to submit those to us in the format we require, which is digitally through our BACKFLOW software, if they forget to do so, it'll look as though your assembly's not tested, and you may then receive a third notice. So if you receive any more notifications, you'd want to just give us a call or email us, and then we can further assist you. Now, let's say you didn't sign up for the gold plan and you didn't meet that September 1st deadline. What ends up happening is we actually will apply a $50 enforcement fee to the water bill. And then we send out our contracted testers to go out and complete the testing. So although it's considered enforcement, and that is, basically our enforcement policy, it's still a pretty reasonable approach and customer friendly in the sense that before shutting water off or any steps like this, we would prefer to just get the assembly tested. That's our primary goal, to make sure that the water system and you are safe. So we apply that fee to your water bill and then send out our testers to complete the testing. And I'm sure that might stir up some questions for you guys, so we'll save those for the end. But with that, I'll turn it back over to you, Steve.
Thanks, Cal. Great job. Good information for what can be a kind of a confusing situation for folks that aren't familiar with backflow assemblies and what they do and the testing requirements associated with them. Kind of to that end, this next slide is just sort of a nice schematic of the anatomy of an irrigation system, if you will, that we wanted to provide just to help folks that aren't familiar with the layout of a typical system. If this is something that's new to you, how you may go about assessing your own system and locating different components. The first thing I'll point you to, if you can see the cursor, is the main meter valve box, which is typically going to be located out by the driveway along the sidewalk. And that's where the water service comes into your property. Downstream of that, you're going to find your point of connection, or where the irrigation system ties into that main service line that then goes into the home or residence. Off of that, you'll generally in fairly close proximity, you'll find some sort of isolation or shutoff valve, either a gate valve or a ball valve, as Cal talked about. Then going downstream to a backflow device. In this case, it's shown as an above grade assembly. However, in most cases, it is going to be a double check valve that is down in a valve box, similar to a meter box, only with a green lid. Downstream of that, you may find a pressure reducer that again will be typically in a round 6-inch valve box or perhaps a metal box. And then you'll go down the main line. Occasionally, some systems have what's called a master valve. And this is just an additional valve that's put on the main supply line that can help you avoid any leaks that might occur along the main line that goes out to any of your electronic valves that control the individual zones or the lateral lines. So it's sort of an additional layer of protection, again, of leakage on a main line. Anytime an individual zone opens up, that master valve is also going to open up, and when the system closes down, that will also close down, and again prevents another layer of security for any damage that might occur to that main valve, either during the course of the irrigation season or during the off season, when typically, if you don't have a master valve, that entire main line is going to be pressurized if you don't shut things down. So just another layer of security. Downstream of that, you'll find the larger 12-inch rectangular valve boxes with the green lids. That's where you're typically going to find your electronic valves. And then downstream of that will be your actual lateral lines, be it a drip zone or a pop-up spray zone or a single stream rotor zone. That is just kind of the general typical layout of an irrigation system. These types of systems are like fingerprints. No two are exactly alike. This again is just sort of a generalized schematic of how how components are generally laid out. And then the last thing we'll talk about is the controller, which is typically going to be mounted inside the garage or on an external wall, typically on the garage as well. And that's where, again, you will do your schedule setting and set the programming to operate the system. So we just want to just remind you, please, if you have any questions, to type those into the chat, and we will address those at the end of the presentation. We're covering a lot pretty quickly, and we really want to make sure that we get to folks' questions. So please do type those in for us. And at this point, we're going to show a short video that will help demonstrate some of the things that we're talking about here today. And to do that, I'm going to turn it over to Andrea, and she will play the video for us.
Okay, well, here we go. It's going to be the ultimate test of technology. Thanks, Steve and Cal, for sharing a lot of information. We'll pick this up here after this short 4-minute video. And if we could remind everyone who's a panelist to mute, because the video, it will sort of play in delayed. We won't all be at the exact same point, so it can create quite an echo. So here we go. I'm going to give it a try.
Hi, I'm Steve.
And I'm Jesse for the Regional Water Providers Consortium. Every spring, thousands of people in the Portland metro area turn on their automatic irrigation systems, and unfortunately they do little else to make sure they're performing properly.
Failing to maintain and tune your irrigation system can result in high water bills and, even worse, a waste of potable water. Here are some irrigation tips that are easy to perform and can save you money on your water bill.
Heads that are damaged or plugged can leak large amounts of water, and the spray patterns will usually not be uniform. This can create swampy, overwatered, and or dry areas as the water is not being applied evenly or adequately in some spots. To correct this, unplug the nozzle by removing it and clearing debris. Tapping on a hard surface will dislodge dirt and debris from the nozzle ports. If it is damaged, replace it with the same type and size. It is a good idea to be consistent with your sprinkler and parts manufacturer, because not all brands are interchangeable.
Watering areas that don't need water, such as walks, streets, or driveways, not only waste water, it can erode and damage the surface and undermine the foundation bed and create potholes. Watering paved surfaces can also wash brake dust, automobile oils, and sludge into the storm system, which eventually pollutes our lakes and streams. You can correct this by regularly observing your system and operating zone by zone and making adjustments so that the water you're paying for is going where it's needed.
As landscapes mature, it's only a matter of time until sprinklers start to be blocked or obstructed by surrounding plants. This can result in overwatering close to the sprinkler head and underwatering in areas that are being obstructed. This problem can be remedied a couple of different ways. Depending on your system layout, you can either install taller sprinklers or relocate the sprinklers or plants.
Runoff is typically caused by overwatering. Excessively irrigating hillsides and watering at a rate that applies water faster than the soil can absorb it are generally at the root of runoff problems. Turf needs on average 1 inch of water weekly. To avoid runoff, learn how to gauge the amount of water your sprinkler system applies and adjust the controller appropriately. Turn on a zone and time how long it takes before puddles and runoff occur. That is the longest period at one cycle you should water that particular area. Use multiple start times with a 1-hour soak in between to give the soil the time it needs to absorb the water being applied and thereby minimizing runoff.
High pressure can account for a 10 to 20% increase in water usage. When water is applied at high pressure, water droplets become very small, resulting in a spray that appears misty. This makes the spray much more likely to drift where it is not intended. To remedy this problem, install a pressure compensating device in either the nozzle, the sprinkler body, or the control valve. These tips, if performed regularly, can easily save you 10 to 15% on your water bill.
They can also improve the overall health and appearance of your landscape and reduce the impact our landscapes have on the rivers and streams of our Oregon home. For more information on improving irrigation efficiency in your landscape, visit the Regional Water Providers Consortium website at conserveh20.org.
The instructional videos listed on our website are general guidelines. The Regional Water Providers Consortium will not be responsible for any damage to your home, landscape, or appliance.
Okay, I'm going to turn it back to you, Steve.
There we go. Sorry, my computer wasn't letting me unmute there. Everybody see everything okay? Okay.
Yes.
Very good. All right, so we're going to pick it back up and go to the next step in our spring tune-up project. And so the next thing, once we have the system pressurized, as we saw in the video, it's important. We want to obviously turn on the irrigation controller to the on or the run position. And a little bit of a pro tip is to refer. Most of these controllers have a door that'll open and close, certainly on the outside manuals versions. But on the inside of the door, there's typically a quick start guide or a simplified operations manual. Make sure you review that and get familiar with the operation of your controller, and you have a pretty good understanding of that. And then even better is to, if you're not familiar, if it's a new device to you, please read through the manual at least once and get familiar with the operation of the controller. When I go out in the summer months and help folks assess high water usage or trouble with their irrigation system, this is very often at the root of the issue is misprogramming of the controller. And I liken it to DVD players and VCRs, if you're even of my generation, and that, everybody had them and we knew how to hit play and record, but nobody really knew how to program them very well. And this is certainly the case with irrigation controllers. And it's just an avoidable situation if you take a little bit of time to get familiar with how these devices function. What we're really looking for is to make sure that you don't have any extra programs or extra start times, and that the run times are appropriate for each zone for the type of sprinklers that you have and the type of plant material that you have as well. The next thing you want to do is, as we talked about in the video, is to kind of go through and assess each zone in the system one at a time. And as you do this, you're going to be looking for signs of leakage, both in the pipes or any areas where water is percolating up through the ground where it ought not be, or any obvious signs of damage to the sprinkler spray itself, any irregularity in the patterns or things that just sort of look off in the way that it's delivering water through the spray. And it's important to repair leaks right away. Don't put it off, because the next thing you know, you're going to get your water bill and wonder how it got so high when you've had an easily remediable situation. You're also looking for accurate spray patterns. Oftentimes pop-up spray nozzles are in a set pattern, be that quarter circle, half circle, or you may have a single stream rotor covering a certain area, a larger area typically. Make sure that water is spraying where it's supposed to spray, and generally to adjust that is a pretty simple thing. And we'll come back at the end of this to talk about the specific tools that you see here in the images. You also want to look for sprinklers that may have sunken or become misaligned over the course of the off season. Irrigation systems are in landscapes that are dynamic. We get flooding, their lawnmowers run over them, kids play with them, dogs chew on them. Sprinklers get misaligned and sunken over time. And so this is where that spade can come in handy, is to just make a slight lifting of the sprinkler or a realignment to get it pointing vertically so that the spray again is being delivered where it's intended to. Just some pretty quick minor adjustments can make a big difference in the efficiency of the system. Now, if you have to make adjustments to the radius of the sprinkler or the distance that the water sprays out from the sprinkler nozzle itself, and or the arc pattern, again, sort of that half circle, quarter circle, full circle, or somewhere in between. Some sprinklers require specific adjustment tools to do that. Most, and what we've got here in the images here are the most typical type of nozzles that you're going to see in a residential setting. On the left, we see what's called a pop-up spray, and those have fixed arcs or a set quarter circle, half circle, full circle. So generally the arc is not adjustable. There are nozzles that do have an adjustable arc, and that is a simple hand manipulation to get that dialed in. If you need to adjust the radius or again the distance, it's simply using a very small flathead screwdriver. And as you can see in that image, there's a small screw in the top of that nozzle, and as Cal mentioned, righty-tighty, lefty-loosey. If you tighten it by turning it to the right, you're going to reduce the radius or the distance the water sprayed. If you turn it to the left, you're going to loosen it or open that nozzle up so that the water sprays out as far as that nozzle will allow it to do. Very simple adjustment, and that's something that most folks aren't necessarily aware that they can do. If you happen to have these multi-stream rotating nozzles, which are fantastic, highly efficient nozzles, they do require a special tool that does both the radius adjustment and the arc, and most of them do have an adjustable arc anywhere down from, say, 30 degrees up to 270 degrees. Generally, the full circles are sort of a standalone sprinkler that is not as adjustable. And then the third that I want you to be aware of is the very common in a larger area is what we call a single stream rotor. Each manufacturer tends to have a specialized tool that you see in the image here, and that tool will help you do three things. And that's one, actually, you can see the rubberized cap, and there's typically 3 ports in the top of that sprinkler, and one will allow that tool to go in and lift the rotor up so that you can actually access the nozzle to clear it or adjust it or change it out. The second port will allow you to adjust the arc, or again, what shape is that area of coverage. And then the third will allow you to adjust the radius. How far does the water spray out from the head? So just, again, good to get familiar with the type of manufacturer's products that are in your landscape so that you can make sure that you have the appropriate tools that you need to adjust the sprinkler nozzles that you have. Oftentimes you can get by with a small screwdriver, but it may get frustrating in dealing with 2 of these higher end type sprinklers that are fairly common. Next thing you may want to consider once you've kind of gone through the system is thinking about, do I have any sensors in my system that I want to take a look at? For example, a range sensor shutoff, which is a device that interrupts the operation of the system if you get a certain amount of effective rainfall. Typically, 1/4 inch is what they're set at the factory, and that's a good place to leave them. The other thing that you may have in the current state of the art is these smaller on-site weather stations that are actually using things like temperature and solar radiation and humidity and rainfall in some cases to make automatic scheduling adjustments. There's not a lot that you can do to fine tune these sensors, but it's a good idea to, one, if you did anything to winterize it, uncover it, and then just get up and take a look at it to make sure that there's no damage has occurred in the off season or no tree or bird debris is impacting the device that might impact its performance. Finally, we just want to make you aware that we've put together this sort of a spring irrigation maintenance checklist, so you don't have to remember everything that we've talked about today or that was in the video, and we will make this available to you after the presentation. I'm not going to go through everything today, but just want to make sure that you know that this is available to you. The one thing I will mention is that second to the last point is signing up for the weekly watering number. We mentioned that in the slide deck prior to the presentation. That's a great tool that you can sign up for free that will help you make scheduling adjustments across the irrigation season based on what actual weather conditions are in our region. And we also have some tools to help you determine, how much water your system puts down and help you set up a base schedule to do that effectively. So just a great resource for you to be aware of. Also want to make you aware of irrigation rebates that we have available from TVWD. If you haven't already, consider upgrading to a WaterSense labeled weather-based irrigation controller. Weather-based irrigation controllers take the guesswork out of irrigation scheduling and automatically adjust the watering schedule based on, again, what are actual weather conditions and on-site conditions. And we have a $50 rebate for those type of WaterSense labeled products. The other thing, as we mentioned earlier, are the multi-stream rotating nozzles. And these are fantastic nozzles that put down water much more uniformly than a typical pop-up spray nozzle will at a slower rate, which is great in our area where we tend to have slopes and heavily clay soils. A slower precipitation rate helps that water actually get down into the soil in the root zone rather than running off into the storm drain where it's much less effective for us. And again, we have a $3 per nozzle rebate available to you. We encourage you to check out the TVWD Conservation website to learn more information about our website and how to take advantage of these rebates. And with that, it's time to turn it over to our comms team and any questions that you folks may have.
Wonderful. Thanks again, Steve and Cal, for a great presentation. And Justin Dyke is going to take over moderating the question and answers today.
Yeah, thanks everyone. So Cal, the first question will go to you. It was posed during your explanation of some of the winterization processes for backflow devices. This customer writes in, after slowly opening the first screw to pressurize, then I would open the other two screws, correct?
Good question. Steve, if you wouldn't mind, could you switch back to slide 10? So just to clarify, if you're referring, there's the 4 test ports that are on the assembly that require the flathead screwdriver to close the 4 of those. And since that step is being completed prior to even having pressure to the backflow assembly, you can close those 4 ports in any order. But I think what you're alluding to here is those 2 shutoff valves, the green handled valves. Back one more. The one just prior to that, Steve. Perfect. And the 2 shutoff valves on the backflow assembly. We would want to open the number 1 shutoff valve first, so that's correct as you had indicated there. And that's after all of those ports are already closed that are on top of the backflow assemblies, as you can see in the picture here, just so you can kind of scope out what I'm referring to. So those top 4 ports are closed. Then you open the number 1 shutoff valve, pressurizing the assembly, and then and that can be done with your hand often if the shutoff valves are in good condition. If you look down in there and those shutoff valve handles are very rusty, you might need to get a crescent wrench or maybe some pliers or something of this sort to get those open, and then slowly opening the number 2 shutoff valve. And that's going to now send water downstream to the solenoid valves.
Awesome, thanks, Cal. We're going to stay with you for the next one. Customer writes in, the TVWD backflow tester checked my system and it passed. However, he left a card that said, quote, number 2 shutoff closed, and checked left as found. However, I did not shut the number 2 valve when I shut the system down last year. Any idea what this means?
So it could be a few things. So it sounds like you were the one who shut down the system yourself last year. So if you're not the one that left that number 2 shutoff valve off, let me first I'll start by saying that testers are contracted testers as well as other testers, but a common practice and what we require is that they leave the assembly in the condition that they found it. So if they arrived and saw the assembly with that shutoff valve already in the off position, they'll only open up what they need to bring pressure into the assembly, complete the test, and then put it back in whatever condition it was when they arrived. And so if you had both your number 1 and your number 2 shutoff valves opened last year, it's possible if you have like a landscape company or a landscape maintenance company that assists with winterizing your system or any maintenance on the system, if they had closed that downstream valve of the assembly, that might be a possibility. That might be the only answer I can think of at the moment, depending upon when that happens in the season. If you had pressure all through the season, it means that those valves were open, because with that valve off, you would get no water to your sprinkler system. So it had to have happened later in the season, possibly just prior to winterization. If you email me, I'm happy to look into your tester notes and see if I can stir up any more information for you on that one, so I can look up your address specifically.
Great, thanks, Cal. And this last question we have is probably going to be for you and Steve as well. Customer writes in, thank you for this helpful presentation. I have some issues in my irrigation system. Do I have to fix it before testing the backflow? And do you provide irrigation system maintenance or services?
So Steve, I can take the first portion of that, and then you can take the latter. So regarding testing the backflow assembly, as long as there's pressure to the backflow assembly and the repairs that need to be made are on the downstream side, so somewhere within your sprinkler system, the backflow assembly can actually still be tested. And basically, as long as the assembly has pressure to it. So if there's sprinkler heads that need to be replaced, or burst pipes or things like this, that you're not at this point ready to send water to the sprinkler system, as long as you can bring water into the backflow assembly, it can be tested. And the reason that we actually still require the assembly to be tested, although some sprinkler systems might be in a non-functioning condition, is, as you can imagine, even as that system is not being used, the water in your lawn still drains back into the piping system through the sprinkler head. So it's bringing contamination in through your sprinkler heads, whether it's fertilization or dog poop, for lack of a better words, things like this, get into those sprinkler heads. And even if it's non-functioning, that's still sitting in a piping system that prior to the backflow assembly is your drinking water. So we still need to make sure that the backflow preventer sitting in between your irrigation system and the drinking water is still functioning properly. And I'll kick it over to you, Steve, for anything you'd like to add.
Sure. Yeah. So in terms of irrigation, no, we do not provide maintenance services per se. That said, I'm always happy to take any phone call and talk about any questions that you may have to help make sure you get pointed in the right direction. If there's been an issue of higher use in the past, or you know, every situation is different, and in some cases, again, if you've had some issues with your system last year and you're using way more, and I can take a look at your water use and it's justifiable to arrange a site visit, if I feel like that's what it's going to take to help you resolve the situation and move forward in a more efficient manner, then on a case-by-case basis we can make that determination. But always happy to take any questions that you have, so don't hesitate to take my contact information and reach out via email or phone call and let me know what you have, and we'll help address the issues and get you off on the right foot.
Great, thanks, Steve. And looks like we've got another backflow question for Cal. Question is annual testing required? I thought I heard it said that it's optional, but maybe it was the gold plan that is optional.
Great question, and something that definitely would be good to clarify. So the backflow testing is required, and it is the gold plan that is optional. So all backflow assemblies are required to be tested once annually, and that's actually So the state of Oregon, the Oregon Health Authority, requires all water suppliers to test backflow assemblies upon installation, after repair, and annually thereafter. And so then us as a water district, we then enforce the annual testing of this by sending out our notices. And so the non-optional part is getting the assembly tested. The optional part is whether you want to find your own backflow assembly tester, to pay them directly, have them come out and complete the backflow testing and submit those results to us at the district, or if you were to subscribe to the Gold plan and have us then charge you on your water bill for that subscription and send out our testers to complete the testing on your behalf.
Awesome, thanks, Cal. And that completes our question and answer period. So one quick final last call. Not seeing any new questions come in. So with that, I will turn it back over to Andrea to wrap us up for the afternoon.
Okay, I just wanted to thank you again for spending your afternoon with us. As a reminder, we did sort of make a link tree page with lots of helpful links related to this topic, so you could find that all in one place. And we put that link in the chat and the Q&A for you. And again, just want to thank Steve and Cal for sharing their expertise, and thank you for joining us. There will be a video as well as a copy of the slides available on our website, probably in the next 24 hours, but it should be here relatively quickly. We get that up for you, and just want to thank you again for joining us, and we hope you'll join us at future Talking Waters.